almost 5 years. And for the last 2 years, I've been closely working in AWS environment. So today, today I'm going to talk about CloudFormation and CDK services. So here's our agenda. And before we start talking about CloudFormation and CDK, we are going to take a look at the common challenges that arise during the development of some small companies during the scaling. And then we're going to take a look how CloudFormation and CDK can help us resolve these issues. So, so, as I said, I'm going to present from a point of view of a small company. And here are a bunch of assumptions that we have. The first assumption is that the company is constantly growing. And the second assumption is that we have a small development team, and our main product is web application. Their technical stack is pretty much simple. I think most of us have worked with something like that before. It is a single virtual machine. It's a REST API, and all the static files are also located in the same virtual machine, basically. And they have a very simple CI/CD process. And to simplify things, they are already hosted on AWS, so they are using some initial basic resources of AWS. So I'm going to be showing some diagrams, some architectural diagrams, and they will involve some icons and of some services. So just for reference, I'm going to just introduce to some of them so that you'll be able to understand. The first resource I'm going to be showing on diagram is RTS. It is a basically service which provides relational databases. And the most popular ones, MySQL and Postgres. There are a bunch of them, but I think for just understanding, for grasping, it is just worth mentioning that they have MySQL and Postgres. The second service is EC2, and basically it's just a virtual machine. So it's like virtual machine in Heroku or any other providers. So the next service is root-free. It provides domain names and it provides also some routing inside AWS. And here's a diagram of their services. So they have a very basic one. They have two environments, development and production. They have very simple CI/CD pipeline, which includes two steps. First, deploy to the development environment, and the second, deploy to production environment. And as I said, they have a single VM in both environments. They have a relational database service. They have root-free for domain name, and for deployment, they use just directly, they go to SSH and deploy the application. And so everything is quite straightforward, and actually it does its job quite well for their scale. So it's not a bad design, it's just pretty much simple, and so I think most of us have worked with something like that. And and the whole presentation will be around the process of scaling. So we're going to be assuming that our company is always growing, which means that we always have more and more consumers. And it means that we need to adapt to the scale. We need to adapt to the load that these consumers demand. And our development team decides to make the first action. So as I said, all the static files are hosted on like the same machine, like HTML files, some pictures. So the first very reasonable action is to add S3 bucket and to keep all the files inside that bucket. And once again, just for reference, so in AWS, you cannot just simply attach two services to each other. They are mostly focused on security. It's one of the most important things for AWS. So in order to get access to S3 bucket, you need to set up also an IRM role and attach to a virtual machine so that it will be able to get access to S3 bucket. And S3 bucket is a service that provides storage for some services. Of course, it has a lot of more advanced features, but for now, I think it's just worth mentioning that it keeps just files and storage files. And yeah, so they made the changes, and they added S3 buckets in both environments, and they also attached an IAM role. So it's very basic first step. However, this step causes a lot of challenges at this point. Let's take a look at the challenges that arise. Yeah, so from this very basic first step, we have already 5 issues. First issue is that it's the manual creation of resources. So it means that the developers had to go to every user interface of every service. They had to go to EC2 service to make some changes with roles. They had to go to IAM roles. They had to go to S3 bucket. So there's a lot of manual action there. And duplication of work, of course, because we had to do it twice. We had 2 accounts, and basically we need to make all the changes twice. The third problem is that there's no single entry point for configurations. It means that in order to set up S3 buckets, we need to go to S3 bucket and define configurations there once, and once again for the another environment. So, and all the configurations for particular services are kept on the level of the services. So if you want to change, for example, EC2, you have to go to EC2 and make these changes. And one of the most common issues in many companies is a lack of architectural map. It may sound very simple, but actually that happens a lot. A lot of times when you have a lot of services, when you have microservices and some relations, you might just forget what kind of resource do you have, right? So it's a very common problem, and we're going to take a look how CloudFormation and CDK can help us there. And also, we have a service hierarchy awareness. It means that when we created that S3 bucket, we had to know, we need to set up a role, we had to know the hierarchy. So it means we had to create S3 bucket first, and then create a role to get access to that particular S3 bucket. So it means that we need to be aware which service comes first in order to set up it. And for such scale, of course, it's not an issue. Like, these are challenges, but they are not very massive. It can be resolved, like manually, it's not a big problem. However, if as the projection grows, it becomes more and more complicated. So if we have like hundreds of services, we need to be aware of their hierarchy, single entry point for configurations. So everything basically adapts. And yeah, let's take a look at the second scaling attempt. The second very basic change. They wanted to change the type of this instance. They wanted to make it more performant, so that it will have more RAM, more CPU resources. So it's very reasonable segment, very simple step. However, sometimes you cannot just simply change the type of EC2 instance. In some cases, you have to set up a new one and then reconfigure everything once again. And our development team made one mistake. So they created a new EC2 instance, but they forgot to delete the previous one. So now we have 2 instances. One is used, and the other one is just useless. It wastes our resources and consumes our money, and yeah. So we can conclude 2 challenges here. The first one is cleaning up the deprecated resources. So since we don't have an architectural map, we have to be aware of resources that need to be deprecated. And of course, it's hard to make some changes to existing resources. We have to go once again to AWS UI and make these changes. And let's take a look at the next step, basically. So they understand that at this point there is no way to change the type of EC2 instance. They need to add more instances, and to be able to distribute the traffic between these instances, across these instances, they have to add a load balancer. So once again, reference. Load balancer is a service that allows us to distribute traffic between our virtual machines. So if we have a bunch of them, if we want the traffic to be equally distributed across all the virtual machines, we can use load balancing for that purpose. Yeah. So they made these changes. They went to AWS UI and they added these new instances. They launched them, and they decided that they don't need to create these load balancer setup, these new instances in development environments because it's very simple. They don't want to have additional costs. However, there is an issue. As you can see, the red line. So they went to metrics. They went to their dashboards, and they found that this resource, these experiences, doesn't have any traffic. It doesn't just receive nothing. It is running, but it does not receive any traffic from load balancer. It means that there was some misconfiguration during the setup. And now they understand that in order to spot these issues at the early stage, they needed to have a staging environment. So which has to be very close to the one which is running on production. And imagine all the challenges that we had before, and now they need to create everything from the scratch. They need to add a new CI/CD pipeline step. They need to create a new environment. They need to set up all the buckets, EC2 instances, load balancers, and basically all the issues that we had, they set up. And we had one more challenge, is working with environments. And and here the CloudFormation. How CloudFormation can help us to resolve, to address these issues. Let's take a look at the list of challenges once again. Yeah. So here our list of challenges, and we're gonna just go one by one and try to understand how CloudFormation could help us. First issue, manual creation of resources using AWS console. It can be resolved by describing your resources using YAML or JSON configuration files. So basically, here is our example. It is a YAML configuration, and so that's our S3 bucket. In YAML, basically it is a list of resources, and it is an array. And the first element of this array is bucket. Type is bucket. We define some properties, and we define some replace policies, etc. And so we can define everything using just YAML configuration file. And let's jump into terminology, because I'm going to be probably using a lot these words. So just for you to know, the template is a configuration file itself. It might be JSON or YAML. And this template basically describes your infrastructure. And stack is a deployed group of resources based on the template. So template doesn't mean that you have some resources, but after you deploy your template to AWS, you have a stack, basically. And you can create a bunch of stacks based on one template. And let's jump to the next problem. It was duplication of work. So CloudFormation can help us easily using single configuration file. And we can use that single configuration file for deploying into two environments. And so it basically eliminates our duplication of work. And we also had an issue with single entry point configurations. We basically had to go to every AWS UI, AWS service UI, and define configurations at that place. In CloudFormation, you can describe your configurations using parameters. So you can describe an array of parameters which can be used in your resources. So let's add some highlighting. So this is our first parameter, and this is our EC2 instance. So as you can see, We can define the type of parameter, we can add float value, we can add some null values, and two micro and one small, and we can add descriptions just for the future, for onboarding new developers to understand what it means. And we can use these parameters as variables and use them inside these templates. And here is the reference to that parameter. So it's, when you create a stack out of template, it takes the value from this parameter, value for instance stack. So yeah, I think it's quite straightforward. And then you can do ways to provide these values. So you can either use, once again, AWS console, but in this case, you will be provided with a page in which you can set all the values for your parameters that you described in your configuration file. And it will also be like very user-friendly. It will add your description. It will also create some select buttons just to select from allowed values. And yeah, so it will be a single page, and in that single page you can describe basically all your configurations, all the values for your configurations, and you don't have to manually go through every service, just one single page for that. Of course, you can also embed that into your CI/CD process using CLI commands. In that CLI command, you can provide the template, your template, and the parameters. So in this case, I provide the parameter value T2 micro to parameter instance type. So yeah, that's how you can add these values, set these values using CLI in your CI/CD process. And the next problem is a lack of architecture map. So this can be resolved using CloudFormation Designer. So once you've uploaded your CloudFormation template, it allows you to create an architectural diagram out of it. So let's take a look at an example. In this example, they provided their templates, and CloudFormation took this template and created a diagram for them. And you can also remember the position so that in the future, when you have a new developers, when you have to onboard them, you can just basically show this diagram, and it will be easier to explain which resources you have. It will be easier to explain their relationships. So basically, it allows you to keep this architectural map for the future, because you won't have the same amount of developers. They're going to leave. They're going to be new developers. So this allows us to perform our onboarding processes easier. And the next issue is service hierarchy awareness. Yeah, so just a reminder, the issue was that in order to create some resource based on another, we need to create a dependency first. So we need to be aware of this hierarchy. We need to know that queue needs to be created first in order for Lambda to get access to queue. So and this can be resolved using implicit dependency based on ref. Let's add some highlight. Yeah. So in this configuration file, I describe two resources. The first resource is a queue, and the second resource is a Lambda. At this point, you can consider Lambda as just a virtual machine, and our next speaker will tell you more about Lambdas. Yeah. So, and yeah. In this example, we want to provide queue URL we want to embed queue URL into environmental variables of Lambda function. And once again, you can use ref for this purpose. And when CloudFormation will create a stack for you out of this template, it will create the tree of dependencies just for you. and it will know that it needs to create queue first, and then it will create lambda, so it will wait until queue is created. So you don't have to be aware of this hierarchy. CloudFormation will do everything for you. And changing existing resources and cleaning up deprecated resources. Let's take a look at this diagram. So when you want to make changes to your existing stack, for example, you have already a group of resources deployed into AWS, and now you want to perform some changes. You can create something which is called a change set, and basically it is done by uploading just a slightly modified version of your previous file, and CloudFormation will create a change set for you. In this change set, it will describe all the changes that CloudFormation will do to your group of resources. It might be deleting the resource, it might replace, it might delete and create a new one, or it can just simply change one value inside the resource. So after you created a change set, you can review that, and if you are happy with the changes, you can just commit the changes, and CloudFormation will apply the changes for you. And this easily resolves our issue with changing existing resources and cleaning up the deprecated ones. So if you define in your new file that something was changed, for example, you removed some instance, CloudFormation will detect that, and it will remove that instance after you've committed the change. And it is also easy to work with environments in CloudFormation. You can use something called conditions to set up, for example, environment-specific configurations. Of course, it's not limited by only this use case. You can make up a lot of things for conditions, but just for the purpose of working with environments, we can. My example will be mostly focused on that. So imagine that for production, by some reason, we don't have to use Bucket. For non-production, we don't have to use Bucket, and we want to create Bucket only in production. So we can introduce a condition, which value is a boolean, and it is calculated during the deployment of stack, and you can refer to those conditions when you define your resources. For example, in this situation, I set the value for condition is production, and if it's not, it will just not create the bucket for me. It will just drop. And if it's production, it will create a bucket. So using conditions, you can basically you can fine-tune your environment. And for example, you don't want to have very performant, very complicated EC2 instances for your staging environment. You can also use conditions for that, and it will create simpler EC2 instances for your staging environments. Yeah, that was all about CloudFormation, and it is a great resource, it is a great service, but there is something called Cloud Development Kit, and which can be described as something like CloudFormation on steroids. Let me jump into the definition. So, AWS CDK is a tool for generating CloudFormation configuration files using a programming language. So here's the list of supported programming languages. And let's jump into the features of AWS CDK. So the first feature is that you can define your infrastructure using programming language. It is a quite simple statement, but there is a lot of complexity and a wide range of possibilities behind these words. So when you have a programming language, you have access to abstraction layers, you have access to for loops, while loops, some conditions, execution controls, if-else conditions, etc. So it is a very powerful tool. And let's take a look at some comparison between CloudFormation and CDK. So once again, our bucket defined in YAML file for CloudFormation. Let's add some highlighting. So yeah, we've already seen something like that before. And let's take a look at the same CloudFormation configuration, but which was created using AWS CDK. So this is how it can be defined using CDK. So basically, you use programming language for defining the same configuration file. Yeah, and it is a lot more convenient for developers. And not only is it more convenient, but it will also allows you to eliminate a lot of additional work with CloudFormation. So the next example will show you the next issue. So this is just a little more complicated example. So in the first piece of code, we create a bucket, and we set some name for this bucket, and then we create a lambda. We set some properties like runtime, Node.js, we add some code, just simple console log. So we add the location of handler, and then take a look at this line. So it allows you to get access for this lambda to the bucket using just one single line. So it's very declarative, and it's very convenient when you can use these sorts of declarations of permissions. And let's jump into the CloudFormation version of this example. So it would be looking something like that. So yeah, CDK basically allows you to eliminate this overhead, because once you have not just a bunch of simple services, once you have a huge environment like consisting of like hundreds of services, CloudFormation templates become just very hard to support and maintain. And let's take a look at the next advantage. Is that since we have a programming language, we can also create shared components across your organization. Let's consider this example. You have a bunch of development teams, and one development team is working on some awesome caching layer. And they implemented that caching layer in CDK, and now they want to share this caching layer with another team. Because we don't want to make them work twice. You just want to share our best practices across organizations, and since we have programming language, we can create this infrastructure, common infrastructure, and deploy it to our shared private registry. For NPM, it would be for JavaScript and TypeScript, it would be NPM. For Python, it would be P, and something else for Java and other languages. So let's take a look at the example. Yeah. So we have a module, our amazing caching layer, and it was deployed by another team into our private organizational registry. So when they share this module, another team can easily access that and create and reuse their components inside CDK. So it is a very powerful tool that allows you to delegate some work. For example, your DevOps team might be responsible for some shared templates for developers, and it's basically immensely accelerates your development process. And so let's take a look at the last advantage I want to share. Is that once again it comes from the fact that we are using programming language. So we can not only share components across different teams, we can also share the code between our infrastructure and application. For example, we have some virtual machine, and there is some production code running in that virtual machine, and there is a CDK which deploys your infrastructure for this virtual machine. And there is a very common issue is environmental variables. So quite usually, when you have environmental variables, they are defined both in code and in the resource itself. So once you deploy something, you need to go to that resource and adjust the values for your environmental variables. Using CDK, you can once again reuse shared code between your application code and infrastructure code. So in this example, I keep environmental variables keys in a separate enum. So we have a queue URL, its value, and this is our application code. So we take these environmental variable keys, we have environmental variables, and we extract environmental variables, referring to that particular environmental variable key. And we can basically push the message that is queue URL, which we extracted from environmental variables. And the next example, this is part of the same example. It is CDK, it is infrastructure code, so it's an application code. We once again reusing this same enum, and we are setting values for these environmental variables inside CDK. So take a look at this line, lambda and environment, and we are using the same enum, the same value, and we are putting the QURL value inside this environmental variable. So in the future, if you want to add something more, if you want to add, for example, bucket, caching layer, and you need to have an access from your application code, you can easily do it using just one entry point for that. Because at this point, yeah, it's very easy. We can just go to that QURL and we can change it twice. It's not a big problem. But once we have a huge application, once we have a lot of resources, a lot of services in AWS, we need to change all the values all the time. It is especially a big issue if you are taking your CI/CD into the next step. And for example, if you want to deploy a new stack for each feature branch. In that case, you can just easily start your feature branch, and it will propagate all the values for your environmental variables using the shared codes between your application and infrastructure. And that's actually it from my side. And yeah, I think we can jump into Q&A session if you have any questions.
All right, there's a question. My question is,
thank you for the great experts to the operational excellence. My question regards to the drawing diagrams, because you've shown us how to define a CloudFormation template from code, or just take the text and then draw a diagram. Is there a tool where I can draw a diagram and then see the codes or see the CloudFormation template, like vice versa?
Yes, sure. It works in two ways. You can not only add your configuration file into that editor and it will show the diagram. You can also create a diagram by yourself, and it will create a configuration file for you.
can I create codes?
Codes? No, you can create only configuration files, YAML or JSON, for deploying the templates that you are describing for your diagram.
Thank you for the talk. One question is pretty CDK is a compiler itself, right? It compiles to CloudFormation, JSON, change set, whatever. Can I add something in the language of CloudFormation, CDK, just like we would add assembly in C++?
Yeah, that's a good question. So this, you mean parts of CloudFormation into CDK? Yes. So in CDK you have different abstraction layers, and you have different versions of constructs. So every plugin that you define is called a construct, and natively it is implemented in 3 layers. The first layer is called L1 construct, and it's basically just mapping to CloudFormation itself. So it just creates, basically we're just creating your configuration files by code. But there is L2 construct. So in L2 construct, there is a new abstraction layer above that, and they encapsulate some parts of the common processes. For example, for creating lambda and attaching the permissions to that lambda, it is a second layer of abstraction. It's not a CloudFormation, because CloudFormation by itself doesn't have that. And they added these features using the capabilities of programming language. So they basically added a new abstraction layer. So yeah, it's pretty much possible. Because it will be the L1 construct, basically the configuration file itself. L3 it is basically your abstraction level for your organization. For example, our amazing caching layer, it is an abstraction over abstraction of native AWS packages. Next question.
What are the advantages of this CloudFormation over Terraform? Because we have application that we set up infrastructure in Terraform, this like AWS services, and why should I use the CloudFormation if I have Terraform?
Yeah, that's actually a good question. Terraform is more powerful. It can allows you. I personally haven't worked with Terraform before, but I know that it's quite cloud independent, and you can basically define your infrastructure both for Azure, both for AWS. However, there is some advantages of CDK, and of course, CDK is very coupled with CloudFormation, so you cannot reuse with another Azure or something, because it is some sort of a native feature of AWS. It is something that they created, and in order to create the same thing for Azure, they would have to implement like something on their side. So the biggest advantage is that you can. It is very developer friendly. So when you have your CDK defined, just from my experience, for example, in my case, we have a separation between infrastructure and development. So our DevOps team members, they usually provide us some sort of templates for us, like a common version of REST API. It will create a common lambda for you, a common API gateway. It's pretty much simple. But if you have just a little bit more complicated infrastructure, if you have, for example, POC, if you need to define something completely new, if you want to, for example, change and compare different architecture designs, it will be a huge delay if you had to always ask your DevOps team to create something for you. And in this case, our developers basically also work with environment. For example, I as a developer can create a bunch of different versions of infrastructure just to experiment with them, just to make some comparison and understand which one is better. So it actually accelerates your development immensely, because developers can use this infrastructure in their very native way, like using the code. And yeah, I forgot to mention one of the big advantages of CDK. If you are using a typed language like TypeScript or Java, C#, they have a great. So the CDK itself is well written, and just writing your code, you can understand which values you should provide. You don't have to jump into AWS documentation all the time, because your documentation basically is provided by your CDK, and it's defined on the code level. So it is a huge advantage, because from my experience, I remember creating these CloudFormation templates, and since there is no something that helps from IDE side, you have to jump into the documentation all the time. Like, you need to have this CloudFormation and documentation on the same monitor and watch side by side. So yeah, developer friendliness is, by my opinion, is one of the huge advantages over Terraform.
Another question. In the beginning, you described like a pretty simple setup of the web application. Could you please tell us elastic beanstalk, maybe compare it with the way when you create CloudFormation templates from code, and you have just code, or you can start with beanstalk and do something there. Maybe they can, I don't know, complement each other, or it's like different ways of thinking about the architecture.
Yeah, sure. So beanstalk by itself, AWS have a different type of resources. There are some fundamental services like EC2 and CloudFormation is one of them. EC2, VPC, and buckets, even bridge. These are all very fundamental resources. And beanstalk is a different type of resource. It is a resource for accelerating development. If you don't want to get into the details of every like VPC configurations, if you don't want to get into the details of implementation of some resources, you can use beanstalk for easy jump. It basically allows you to easily create something new very quickly, very fast, without engaging into the ecosystem of AWS. And beanstalk is essentially based on CloudFormation. Beanstalk creates CloudFormation template, and in Beanstalk you can also add additional resources. You can create that resources field in the Beanstalk configuration file, and you can describe all your additional resources in the same way you would do using CloudFormation. So it's basically something which is built on top of CloudFormation.
Can I use what?
In Beanstalk? Yeah.
Create CloudFormation.
No, cannot.
Not really a question, and then a question. First one is, Davron is not fair to compare with CDK because two different things, absolutely. Terraform is being compared with CloudFormation because CloudFormation is grabbing AWS resources, managing them, and Terraform is doing that. And the CDK is just a layer of abstraction upon CloudFormation. Next one is, can I write custom resources in CDK or custom resources in CloudFormation? Can I add them to CDK? How is that integrated? Custom resources as in, you write code, you start,
Like custom resource, you need specify what custom resource.
And we have a library in Python that's a CFI response, which, so basically CloudFormation gives you an URL and you run a code, it has some kind of timeout. You can write custom resource in your Lambda, which will discern, which can manage actually your infrastructure itself. But this is a feature of CloudFormation because CloudFormation does not support all the resources in this way. It might not. So we have a custom resource for that. That's what custom.
Yeah, actually I haven't worked with that, so I think I just take a look. That's
We will have one more question right here, I guess. Yeah.
So aside from creation of resources, does CDK allow managing and monitoring configuration?
does CDK allow managing the values for configurations?
Yeah, maybe changing them and monitoring configurations.
Yes, usually it is done with something like configuration file. And its configuration file itself that consists of just a bunch of values. So which you define your CloudFormation CDK code. So usually it just needs your configuration file and the created resources. So then if you want to change something in the configurations, you basically make the changes to the configuration file, and after you deploy it once again, it will take the values and the change basically the resources. Does that answer the question?
Yeah. And does something
Yeah, sure. So it doesn't have a native feature for working with versions, but you have a Git. And basically, you can commit your changes in Git, and that will be your version control. And if you want to roll back your version of infrastructure to something previous, you can just switch to that previous commit or revert to that and deploy it once again. So it's quite stable.